Okay, let's look into this question. Somebody asked me to solve this one. You're on a hike. Your camp is 15 kilometers away in the direction of 40 degrees north of west. The only path through the woods leads directly north. If you follow the path 5 kilometers before it opens into a field, how far and in what direction would you have to walk to reach your camp? Actually, it's a solved question from your textbook, but there is an easier method to solve this. In the textbook, they've used the component method, but I'll show you an alternative, easier way to solve this. Now, let's sketch this one. It says your camp is 15 kilometers away in the direction of north of west. So if you draw the directions, so that's north, south, east, west. 40 degrees north of west. So you have this line, this angle is 40, right? North of west. So you go from west towards north, that's 40 degrees. And this distance is 15 kilometers, right? So that's the first statement that we have sketched. And then the only path through the wood leads directly north. Means you cannot travel this way. So you have uh, walked, let me choose a different color. Okay, here the only path the wood leads directly north. So you travel north straight up here, but your destination is this point, 15 kilometers directly from here at 40 degrees. So here you're walking 5 kilometers before it opens into a field. Then you can walk in a uh, in this direction. Okay, till 5 kilometers you don't have an option, so you're walking up north. How far and in what direction would you have to walk to reach your camp? So you need to find out how much more you need to walk to reach this destination, right? So that's the distance, the magnitude, and the direction you need to find out. So read the question carefully, sketch this diagram. So I'm just going to redraw now only the three sides of the triangle that we are connecting it with a vector. So this distance is known to me, which is 15 kilometers, and the outside angle is 40 degrees. Then you have a vertical length here. This is 5 kilometers, and I need to find out this distance, right? So you have a triangle here. Now, what would the angle inside be? So first step is I want to bring in an angle inside the triangle. So this we know that's 90 degrees in total. So the inside angle would be 50 degrees, right? Because this is 90 degrees. So the angle inside the triangle is 50 degrees. So I can use directly cosine rule. Why? Because I know the two sides and the included angle, and I'm finding this distance. That's cosine rule, right? So I apply cosine rule to find this distance. So if I take that as d, so d equals square root of a square, that's 15 square plus 5 square minus 2 times 15 times 5 times cos 50 degrees. Two brackets, and as I keep telling, if you have your calculator one bracket here, you need to close it with another. Square root of the whole thing will give you about 12.4 kilometers. All right, there's an easier method because we didn't have to do much of calculation. What you had to do was to understand the situation, label all the sides and the angles properly, and bring it into uh, a proper triangle with some angle, known angles inside the triangle. Then it's easier. In the textbook, they have solved it by using component method, which is also an alternative method. You split it into 15 cos 40, 15 sin 40, and then subtract it from 5 and make it into two 90-degree components, and then you calculate the Pythagoras theorem. That's a bit lengthy, but this gives you in one step the answer. Now we have found out how far. So the distance is found and in what direction. For direction, you could use sine rule. You can find the angle by using these opposite sides and opposite side and angle. So I start with 15 kilometers, and this is the angle that I need to find, right? Because you're taking a deviation from the north, from 5 kilometers, you're taking a deviation. So I need to find this angle. So I take that as theta. So 15 upon, oops. Sorry, actually that got, I'll add it in another video how to find the angle theta.